And since I'm checking, might as well check the recording is actually happening. Yep, it is happening. Thank you. Okay, so this is these are the two pictures that we presented on Monday when we talked about the mechanism by which a parameter can be passed a reference to an object that is a subclass of what it is expecting. So in the first picture right here, the blue triangle represents a superclass. Basically, it's a class where the other two classes, the teal and also the burgundy classes, inherit from. As a parameter, you can pass, you can specify the type to be of the blue triangle, but if you try to pass a reference to an object that is of the teal color or of the burgundy color, it's okay with Java. Okay, you can always use a reference of a object of a subclass and pass that reference to a parameter of a expecting a superclass. Because when you are going from a subclass to a superclass, you're just losing information, and losing information is no big deal. Okay, it's basically just saying, okay, we are now no longer accessing the part that is in teal or the part that is in burgundy in that triangle, which is okay. Okay, all object-oriented programming languages allow or support the passing of a subclass to a superclass without any explicit casting. Yep.
Let me double check mine. But if a subclass modifies the method, right? When you pass it in with that specifies a parameter as a superclass of it, it will use the method of the subclass?
Yes, unless it is a static class, and unless it's a static method. Okay. If it's a static method, it's associated with the class itself, and so there's no overriding, or there's no way to override a static method. But if it is overridable, it is in C++ terminology, it would be a virtual class or a virtual method. So it is quote unquote sticky because it sticks to the object itself. It's not sticking to the class, but it's sticking to the object. So when you pass an object of the subclass and it overrides a particular method, when you pass a reference of that object and cast it to a reference to a superclass, that method, as long as it is still visible because it is a part of the superclass definition, whatever you use to override the superclass method will still be effective because it's sticky to the object itself. Okay? But the whole point of this picture is, if you look at it like this, in other words, if you look at this picture, you can only have one superclass because the superclass has to do with the offset from the beginning of the entire object to a particular point. In this case, the yellow dot represents a method. That offset has to be constant, okay? Because that's what the subroutine being called is expecting the method to be located. So if you move that yellow dot somewhere else, then it would not be able to find it. And that's why there's a limitation of each class in Java can only have up to one superclass. They may not have a superclass if that it's already the first class where it's not inheriting from anything, but you can only inherit from up to one class in Java, and this is the reason. Now, but that is a very strict requirement, because if you want a particular object to be able to pass to a particular method, then that by itself is going to lock down your chain of ancestry, because it has to have have that one superclass somewhere along the superclass inheritance chain. And that's a big restriction because it cannot be of any other cannot be a subclass of anything else in Java. Are we doing okay so far with that restriction? It's a very, very limiting restriction, and that's why typically we don't want to do things this way. We don't want to place restrictions unnecessarily on the objects. The second picture reflects what happens when we use an interface instead of the class hierarchy to do abstraction. Basically, we are looking at things, but from a more kind of simplistic view. In the second picture, the triangle is still representing the inheritance hierarchy. The blue one being the superclass, the teal is a subclass of the blue one, and then the burgundy, or in this case it looks more like purple, is a subclass of the teal one. Okay, but the inheritance in this case is not important at all, because the red rectangle is an interface, and the burgundy triangle, the big triangle, implements that particular interface. And the way the interface works is a mapping. Okay. In other words, as long as the class that is implementing has a yellow circle and an orange circle, the implementation is okay. The compiler would just say, "Yep, it's okay," because there's a yellow circle here and there's an orange circle here. They match the color of the interface and they can do the mapping. Now, what we represent here as a color, for identification purposes, in the case of the compiler, it would be the return type of the method, it will be the name of the method, and it will also be the types of the parameters of the method. So if all of those items match between a method defined by the class and the definition in the interface, then the mapping is possible and the class can implement that particular interface. Is that okay so far? Yep.
In this case, the burgundy class implements the interface, right?
The entire rectangle, yes. The entire rectangle implements the interface, not just the burgundy portion, because the burgundy portion is the extension on top of the teal portion. The teal portion is an extension on top of the blue portion.
Yeah. But in the Java language, you would say the burgundy implements that interface, right?
The green interface, yes.
The green interface.
Yep.
But then it does not necessarily have to implement the yellow method
in the burgundy portion.
In the burgundy portion.
Because
it being implemented.
Yep.
Okay.
Because in this particular case, if you look at the Java code, it's going to say the burgundy portion extends the teal portion. But when you look at the teal portion, it extends the blue portion. And by inheritance, the burgundy portion automatically has access to the yellow circle. So by the time you talk about the purple class or the burgundy class, it actually it has both the orange method as well as the yellow method.
Yeah. So the blue, when you implement the blue class,
when we specify or define
yes.
the blue class.
When you code up the blue class,
right?
You said it implements the green interface.
No, the blue class cannot implement the green interface because it is lacking the orange bubble.
Okay. So
because
it know anything about the yellow method.
It only has the definition of the yellow method, but it cannot implement the green interface because a green interface requires both of those colors.
Okay.
So in this picture, only the burgundy subclass can implement the green interface, because only at that point we have both the yellow and also the orange circles.
Okay.
Now, if you have subclasses of the purple class, obviously all of those subclasses can also implement the green interface. Yep.
In the blue class, there would be no point in implementing that green interface, though, right?
You cannot.
If you just wanted yellow, because it's already a method of blue, so it wouldn't make any sense, right?
Well, it cannot. Well, it just cannot implement the green interface because it's lacking one of the methods.
Yeah, it's just for me, what bothers me is the fact that the yellow method has a signature, right?
Mm-hmm.
It has the parameters in and out.
Right.
Right. But it does not. How do you know what those signature is, right? When you compile blue, it doesn't. There's no way of checking.
Yeah, but when you compile when you define the blue class, you cannot implement the green interface anyway.
Yeah.
By the time you compile the teal portion, you cannot implement the green interface.
Yeah.
It's only when you compile the definition of the burgundy or the purple portion, then you can implement the green interface. But because the purple portion inherits from the teal portion, and the teal portion inherits from the blue portion, so by the time we actually compile the burgundy portion, even if it is in a different package altogether, but because of the use of the word import, by the time we compile the definition of the purple portion, it knows that it has the yellow, circle because of the import.
So it's during the compilation of the burgundy, that's when it checks whether the yellow method was implemented correctly.
Whether the yellow method is inherited, right?
Oh, okay.
Yep.
What if the yellow is overridden in teal?
Then the teal version of the yellow bubble is going to be used. Because when you override a particular definition, a particular method, remember the picture? We had the method table. It doesn't change the offset of that method from the beginning of the entire table, which is the important part. But you're not adding a new entry to the table. You're overwriting a particular entry that it was there already, and the green interface will pick up the new definition. It will pick up the overriding definition, not the overridden definition. Okay, those are all very good questions. Any other questions about this? The differentiation between the mechanism of using inheritance versus the mechanism of using an interface. We also talked about the analogy of inheritance, like in real organisms, like us, right? So genetically speaking, we can only inherit from our two parents. That's it. Okay, we cannot say, oh, I want that gene to be tall. I want that gene to be, tolerant to alcoholic beverages, right? Or I want that gene to be tolerant to tobacco smoke. Okay, you cannot just take and pick. You can only inherit from your two parents, but your role is not limited to only one role, right? You can be a teacher, an engineer, a student, customer, when you go shopping, and so on and so forth. A driver when you're driving a car. So when you look at inheritance, that's basically inheriting the genetic makeup of your parent, which is represented by this picture here. It's very restrictive. You can only have two parents. But when you look at the interface, it's more like defining a role. Okay, do you have the ability to play this role? Well, certain abilities are required to play certain roles, right? If you want to be a basketball player, you need the mobility and the sight to become a basketball player. So the bubbles or the circles here are basically just stating, in order to play this role, you need to meet these requirements. But as long as you meet these requirements, I don't care about your inheritance. Okay, who's your father, your mother, and your grandparents, and so on and so forth. As long as you have these traits, you can still be a basketball player. Am I making any sense? So that's why the concept of an interface is so useful, because it is much more flexible in order to have the abstraction. Now, what kind of abstraction are we talking about? Let's talk about not just the definition, but also how. Excuse me. One more, thank you. Okay, so let's talk about not only from the definition perspective of implement versus extends, because with class hierarchy it is extension, with interface it is implementation. So from the application perspective of how we use these things, it has to do with when you have an object of this particular class or a subclass thereof, you can pass a reference of that object to a parameter expecting a reference to an interface of the green interface. So it is abstraction because by the time you only have a reference to using the interface, you have lost everything that you know about the entire rectangle or triangle, except for two things. Which two things do you still know about that object? It has a yellow circle and it has an orange circle. So by the time it becomes a reference to an interface, the green interface, you have lost everything. You have lost knowledge of everything about the blue class, the teal class, or the burgundy class, except that combined they have a yellow circle and an orange circle. Those are the only things that you know about the object that is being referred to. Am I doing okay so far? But with the other method, when you cast a reference to an object of the burgundy class and you cast it by passing parameters or assignment statements to a reference of the blue portion, guess what? You don't just know about the yellow circle here. You know everything about the blue triangle. Okay, they're both methods of abstraction because you are losing details, but the way it works is entirely different because one is based on mapping, which is basically just picking, choosing, and selecting what you want to expose through the interface, and that's it. Nothing else gets past the interface. And then the other one is inheritance. Basically, you're just losing definition of subclasses. Yep.
I don't know if you answered this or not, but in an interface, can you have more than one method from different classes, or is it just one?
Absolutely. That's also one of the attributes of interfaces. Is a single class can implement any number of interfaces, which is really cool because now using one single class, you can say this class implements this interface, this interface, this interface, and this interface. So an object of that class, or a reference of an object of that class, can now be passed, to any method expecting one of the interfaces that the class implements. That's quote unquote, how Java implements polymorphism. It's a term in object-oriented programming. Basically it's saying, this object can be seen in different ways, and this is one way to implement true polymorphism in Java. Not through inheritance, but through implementation. The concept of an interface is missing entirely from C++. They use, but they do allow multiple inheritance to do about the same thing. Okay. So are there any questions about these two pictures? I know it's kind of theoretical. It talks about the programming language itself. It talks more about object-oriented programming paradigm than app programming. But I think it is kind of important to understand this aspect of how an interface is used before we actually utilize that in our program. So I'm going to skip this part because we talked about it on the other day already. And for the most part, it is really just giving you a kind of preview, or not a preview, but giving you an overview of what happens when you touch a particular button on the screen. Okay, but it does explain what a callback function is, or what is a callback in that case. So now we want to say, okay, now I want my own logic to run when a button is clicked. Okay, the first method is to use a subclass of the method button. Use a subclass of the class button. That is found in the package called android.widget, and this is one way to do it. So what you're doing is button as a class already implements onClick. Okay, it defines onClick as one of its methods. So what you can do is you can define a subclass of button, and then in your subclass you will redefine or override the definition of the default onClick method, and as a result, when you create objects out of your subclass, they know everything that button can do, but on top of that, they also have the overriding definition of onClick to do what you want your button to do. The problem with this approach is, one, you have to make a whole class definition, and then the second thing is this class definition natively has no knowledge whatsoever of anything else in your application. In other words, this is a class that is completely standalone. It has nothing to do with your activity class. Now, most applications will define or include a lot of fields, as instance variables and whatnot, in the subclass of an activity. In other words, the class that is representing the screen or one of the screens of your application typically has a lot of properties that you can interact with, as a part of the application. This button has no knowledge whatsoever of that, application object. And as a result, you have to reestablish those connections. You have to tell the button and say, you know what, you are a button of this particular, activity. And then at that point, your button will have knowledge of, okay, I guess I'm part of this screen here. So when I need to trigger an operation and it requires, information from the rest of the activity object, this is how I can get to those particular attributes. It's not convenient, okay? It can be done, it's just not convenient. The other part that is not convenient about this approach is you will have to modify or specify to create a button to create a button object out of this subclass instead of the usual class of button in your XML file. One of the XML files has a place to define that. I promised you the other time on Monday that I will know how to do it. I forgot about it completely, so I'm going to look up how to do it now. So Android button subclass in the XML file. I think last time we looked it up too. Subclass button with Android. Lots of errors. Okay, how to extend? I try not to use Stack Overflow, because Stack Overflow is not a part of the actual Android documentation. So whenever possible, I want to refer to the Android documentation instead of Overflow. Stack Overflow. Stack Overflow does have one advantage. The advantage of Stack Overflow is the same advantage of Wikipedia, which means the many eye paradigm sort of works. Okay, in other words, there are multiple people who would go over those questions, and if they spot an answer that is not entirely correct, other people can jump in and say, hey, that's not entirely correct. This is the actual answer. Da 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 da. But then you're relying on other people to jump in. So what if someone gives a wrong answer and nobody had a chance at that time to correct that wrong answer? Well, then the wrong answer is published, right? Okay, so the layout, and I'm going to just look for subclass here. Declared UI element. Okay, so I'm going to look at the layout params of classes has its own syntax. Doesn't have the quick answer that I was expecting. Creating a view class. Okay, so define custom attributes, because you have to use a subclass to create this particular object. So in resources, this has to be named a pie chart. And there we go. So this is how you tell the Android tool, the Android tool that puts the application together. This is how you tell it, which subclass to use to create a particular object. And once you define the custom attributes, you can use them in a layout XML file, just like built-in attributes. So this is actually a part of the layout XML file, which is related to the activity that this layout is related to. So I was actually looking at the right place last time. I just did not know, how to specify the tag in this case. So basically, that's the tag that you use inside the layout file to specify, this particular object is of this subclass. But that's what you need to do in order to use your custom subclass, with any type of screen element that you want to associate it with. Now, this method makes sense in some cases. So let me switch back to my notes here. The method of using a subclass of button makes sense when you need to stamp out many of these buttons. So depending on your app, okay, you might have an application where you want, like 20 buttons on the screen to have the same kind of behavior, the same kind of attributes, and so on. In those cases, this makes sense because you're defining a cookie cutter, and this time you're going to use the same cookie cutter to make 20 cookies of the same shape, same attributes, and so on and so forth. And it makes perfect sense to use a cookie cutter in this case because the other two methods will either be impossible to do this, or it will be very cumbersome to do the same thing. Okay. So once again, if you want to stamp out multiple elements, user interaction objects that have similar behaviors, then it makes sense to make a subclass. Even though using this method, you have to go into the XML file to do some modifications. It still makes sense in that case. But what if it's a one-off button? Okay, like start. Okay, you have only one button that has to do a particular thing. Then it doesn't make sense to go through all the trouble to do this. You can do it, it's just not worth the trouble. The second approach, not using a button subclass, is to use a single callback method. The way you use a single callback method, the best way to do it is to illustrate it using the code here. So this is a partial program to illustrate how to use the interface concept. But this time we can only override the behavior of one single button in this case. Okay, so let's take a look at this code here. If you look at this code here, let's look at line 7, which is the first line of the definition of the myActivity subclass, which extends activity. Can anyone remind me what is the use of an object of the class activity, or a subclass thereof? What does it represent? What?
Screen.
The screen, exactly. So an activity in Android terms is basically referring to quote unquote a screen in other contexts. Okay. So my activity is a subclass of activity, which also means that this is my custom screen or an object to represent my custom screen. This part we fully expected because it extends activity. It is a subclass of a regular screen. So we naturally want to inherit everything that a default screen can do. It can by default handle what happens when the back button is clicked, and amongst other things. It has a default color, default layout. It knows how to load its own layout so that we have all the objects, all the buttons and text boxes and whatnot placed on the screen. So we want all that stuff, and inheritance makes perfect sense in that case. But this is the weird part, because it is also implementing on-click listener. On-click listener is kind of the green rectangle that we saw earlier. It is the name of an interface. Okay. So now we have the subclass that is representing a screen also acting as a interface so that it can be a callback function. Okay. So let's take a look at what is that going to buy us. Yep.
What's the difference between implements on-click listener or within the code, say interface touch?
Okay, what is the difference between
this way of presenting or introducing the on-click listener interface and the other way of actually calling an interface with like some other name and then defining the interface?
calling an interface another name?
Yeah, like there's a keyword where within the code you just type an interface, just like when you say public void or I mean you just type an interface and that actually declares an interface or defines an interface.
I'm not aware of that mechanism.
That's just, I think, the definition of the interface. This is the implementation of the interface.
Yeah, that implements it too. I mean, if you define an interface.
Well,
I
it
think
is-
you're talking about a nested definition of an interface within a class.
Yeah.
This one is using an interface that is predefined by the Android platform or the Android framework. So we are using an interface predefined because an on-click listener is what is the type expected by the method that you use to set up the callback. Okay, so we'll take a look at why that is actually significant. Okay. Okay, but as a on-click listener, okay, in order to meet the requirements of this interface, remember an interface is like a filter, okay? It's basically saying if this class can do this, it qualifies to be seen as an interface like this. Okay, that's basically what an interface does. So when we say that this class myActivity implements on-click listener, it is placing requirements on the class that I'm defining because it has to meet certain requirements. In order to meet the requirements of on-click listener as an interface, the class itself has to implement a method called onClick. And not only that, the return type has to be a void. It cannot return anything. The name has to be onClick, and it can only expect one and only one parameter of the type view. Okay, now in this case, view is a class, not an interface. Yep.
So this myActivity class would be like the burgundy triangle?
Yes. Yep. It will be equivalent to the burgundy or the teal. No, it has to be the burgundy because it has the last bubble, that is needed in order to implement the orange interface. Yep. Or the orange circle in the interface. Yep.
A while ago, you mentioned about nested interface. Will you discuss the reason why you would implement nested interface?
Why I would implement
Nested interface. The one that you-
nested? It's used internal to the class definition. In other words, the interface definition is not seen by anyone else.
Yeah.
It's seen inside the class.
Yeah.
Sometimes it can also be exposed. In other words, you can make an interface definition inside the class be public. Then it can also be seen by the outside world. In fact, here we have just seen one example. Look at the import line on line 3. What does it say? The first part in lowercase, it tells you that it is a definition in the package called Android.view. Okay, that part we know because by convention in Java, lowercase characters will be used for package names and uppercase characters will be used for class and also interface names. So next is view, right? So we know that view is probably the definition of a class. And then we have onClick listener. That means onClick listener is actually an interface defined inside the class view. So that's how it is nested, because you have an interface defined within a class. Now there is an advantage to that approach because an interface defined within a class has visibility to other things defined within that class.
So when you define an interface within a class, does that class necessarily have to implement that interface, or
No.
is it no? Okay.
No, because you are leaving it to somebody else to implement the interface.
Okay.
It's just giving it the option to.
Say again?
You just have the option to use it.
Correct.
Okay, so if a subclass of
View.
a class, a superclass that has a nested interface, does it necessarily have to implement the methods of that interface?
Not if it is just referring to the definition. Okay. In other words, a class can have a nested definition of an interface,
Yeah.
but that class itself nor its descendants needs to implement that interface, because most of the time the whole point is for somebody else to implement that interface, so that you can use that interface as a type to a method of the containing class itself.
So if a subclass wants to implement a nested interface, then it would have to specify implements.
Correct, and I'm not even sure that it's even possible for a class to implement its own nested interface definition. It may be possible, but I'm not 100% sure about that one. But in this case, this interface on-click listener is a definition inside the class definition of view, and that's because view itself doesn't need to implement on-click listener. Somebody else typically would implement it. So in this case, we have my activity, which interestingly is also a descendant of the view class, implementing the on-click listener. Now the requirement to meet in order to implement on-click listener is the class that is doing the implementing needs to have the on-click method. And the on-click method needs to match the signature of the interface, and this is the signature. Return type is void, on-click is the name, and it needs one parameter called view that has a type of view. And here, now I can specify anything that I want to do when a button is clicked. Am I doing okay so far here? Okay. Now, there's a marked difference between this approach and the previous one. The marked difference, or the main difference here, has to do with this on-click method has full access to everything else that my activity knows. Is that okay? The other one does not. Because if you look at the inheritance, in this case, this interface is implemented by my activity, and my activity is the one class that is representing the screen. If you look at the previous approach, this my button, which has the my code to specify what to do when the button is clicked, is inheriting from the superclass button, which has no linkage whatsoever to the subclass my activity, which is representing the screen. So that means if you want the button to check this and that and whatnot before it actually does an action, if the requirements are not met, it'll pop up a dialog box and complain. This button is going to have some problem doing it because it has no access to the text fields of the screen. It has no access to the internal data of the screen. It has nothing. It has access to nothing of that particular screen unless you specify a reference inside this subclass to point to the activity that it's related to. Then inside this code, then you can refer to it. But you need a separate method to say, hey, this button, go ahead and link up with that activity object over there. So it takes extra work to do it. It's not like it cannot be done. It's just that you have to do some extra work to make it work. Am I doing okay so far with that concept? So it's not, this approach is general, okay? It can do everything that the other two approaches can do. It's just not handy when it comes to one-off buttons where I just need one button to do one little special thing. I don't need to stamp out 20 versions or 20 instances of the same thing. This is really great when you need to stamp out something like 20 times or more, but it doesn't make sense when you have a one-off kind of thing and just say that this is the one button that I need to do something special. I don't need to go through all this trouble to do it. The second approach, which is the one that we were talking about, this one is good for certain types of situations, especially when you only have one button on the screen. The problem is, what if you have two buttons on the screen? Okay, let's finish this one first. Okay, let's finish this one, and okay, this is just the definition of what to do when the button is clicked. But at this point, if you just look at this portion of the program, does it say which button is going to perform these operations when it's clicked? No, it doesn't. It doesn't name the button, right? So what you need to do now is when you are creating the screen, when the screen was initializing using the onCreate method, Yep, go ahead.
Isn't it true that when we implement the on-click interface, on-click listener, that it doesn't have to be a button. Anything that you click on the screen will generate or will send something to the on.
It doesn't know anything. Okay, up to this point. Okay, up to this point, we convince the compiler. Okay, we convince the compiler and say that this class meets the requirements of the on-click listener interface. The compiler will look into the definition and say, yep, it does because it has a method called onClick. It has the right return type. It has the right parameters. So everything works as far as the compiler is concerned. But there's no code up to this point, up to line, we have to kind of scroll it, up to line 12, okay? Up to line 12, nothing says anything about which button is using this on-click method. In fact, you can have a screen with no buttons whatsoever, and the compiler will still say, yep, it's okay, I have a method. I don't know who's going to use it, but I have a method. Are we doing okay so far? So you define the method, you define what to do, but you have not said who is going to use it when it is clicked. Yep.
On-click listener only has one method.
On-click listener is an interface. It specifies only one method. Yes. And it's on-click. So that's why you can define any class with only one method, which is on-click, and that class can implement on-click listening.
So you said interfaces are kind of like a filter.
Yep.
And you can pull methods from different classes. Where is on-click listener pulling its method from?
Whatever class is implementing it. Okay, if you look at the picture, if you look at the triangles, come on, move. Oh, wrong way. When you look at the triangles, if you look at this one here, if I have the entire thing in blue, it's okay too. If the blue class is defining both the yellow and the orange circles, it too can implement the green interface. It's just that I use an example where a part comes from the superclass and a part comes from the sub-subclass. All right, so getting back to this code here. So up to this point, from line 7 all the way up to line 12, all we are saying is this is a subclass that is inheriting from activity, and it meets the requirement. It's expected to meet the requirements of on-click listener. Inside the class definition, we are defining on-click as a method. You can define any method in any class, right? And in this case, this particular definition from line 8 to line 12 is going to convince the compiler, and the compiler will say, okay, I know that this class can implement on-click listener because it is providing a particular method called on-click with the right return type, with the right name, and also with the right parameters. But up to this point, I can have no buttons whatsoever on this screen, and this method is just sitting there making the compiler happy and have no advantage whatsoever at runtime because nobody knows about it, nobody cares about it, nobody's going to trigger the execution of it. Are we still doing okay so far? So the magic of the next few lines is how do we associate this particular method to the button on screen that we actually want to do this thing when it's clicked. So that has to do with line 15 and also line 16. So we'll take a look at line 15 first. They're a part of the method on create, and here I kind of forgot to put in something here. It will still compile. It's just not the best way of doing it. What did I miss? Sorry?
The new word?
Nope. I forgot one little thing that is actually kind of important. Well, a few things, but let's focus on the first one. Okay, it has to do with the my activity extends activity. Activity has its own onCreate method already. Override, exactly. Okay, I forgot the @override. Now, if you forget the add override, the compiler is still happy, right? The compiler is just saying, well, it's okay. If I find that the superclass has a definition of onCreate already, I'll automatically do the overriding, no problem. If the superclass does not have the onCreate method with this signature, then it will be unique to this class. It will be unique to the subclass and not known to the superclass. So the compiler will make the decision and say, either way is okay with me. But my intention is to have onCreate to override the onCreate of the superclass. That's my intention. So if I have a typo here, if I miss the last E of onCreate and it becomes onCreate, the compiler is not going to complain. It's like, okay, you want to define a new method? Be my guest. No problem. Syntactically, it's all correct. So I would end up thinking that, okay, I have all these extra things that I want to do with this subclass of my activity when it's initialized. But in reality, nothing is getting done because nobody's going to trigger onCreate, right? The misspelled word when the screen is initialized. So that would not be good because it's a mistake, it's a typo, very simple mistake, but yet the compiler was not able to catch it. And I may not be able to catch it either until I try to use something that is specific to this particular screen. Is that making any sense? If I use at override right before this definition, then the compiler would do some extra checking and say, okay, well, since you think you're overriding a method of a superclass, let me double check that the superclass in fact has a method like this with this signature that you're overriding. If the superclass does not have onCreate, which is the misspelled one, then the compiler will come back and say, haha, you thought that you were overriding something, you're not. So at compile time, I instantly know, okay, I had a typo, fix that problem, recompile, compiler's happy, now I know that I got the program done right. So that's why it's kind of important to have the at override, they call it annotation, because it's telling the compiler something about your intent of the program, and so the compiler can, based on your intent, do some extra checking. Not just syntax checking, but also how you use specific definitions in this case. So that one is kind of omitted here, but it will still compile. The focus is not that though, over here. The focus is on line 15 and line 16. So let's go ahead and take a closer look at line 15, which is this one here, and also line 16, which is down there. These two lines can be combined. In other words, you really do not need the variable b as a go-between between these two lines. Okay, let's take a look at line 15 first. Line 15 says b equals, and then we have a cast operation, button in parentheses, find view by ID, which is a method of the view class, and then we have r.id.buttonName as the it actually refers to a instance variable in this case of the class R, and inside class R it has a object ID, and then inside the object ID it has button name. And all of these are static. In other words, you cannot create an object of class R. Class R is a static, has everything being static here. Okay. When you look it up, r.id.buttonName translates to a single integer. Okay, it is just an integer value. But that integer value is unique to this particular resource. In other words, it's identifying an actual button on the screen. It's identifying, a particular resource, and this resource is the button that you are using in this particular application. So what find view by ID is really doing is it is returning a reference to a view based on the ID within the resources. Are we doing okay so far with that concept? You're looking up, using the unique integer value of a particular resource, and you're basically asking the Android platform or the Android framework, and you're saying, okay, I got this ID here of the button that I want to access. can you give me a reference back, to that button? That's basically what you're asking from the Android framework.
So where is this button object being created?
It's created prior to this call here, because I missed another thing. Between line 14 and line 15, I'm supposed to also call super.onCreate. In other words, I'm supposed to tell my superclass method and say, hey, you do your work first, and then I'll follow up with my custom stuff. So by the time it gets to line 15, that object should be created already. Yep.
Is find view by ID efficient?
It may not be, but it doesn't matter because we only do it, in onCreate.
I mean, in general, because
In general?
you could be using a loop, which you may be forced to use find view by ID.
A lot of times,
Yeah.
right? Because everything is integer, the ID itself is an integer, I would expect the implementation to be using a table or an array of references. And this is really just doing some simple bound checking, make sure that the ID or the integer that you pass is within the bound, and that's it. So I don't think it is inefficient, but I have not seen the actual implementation of find view by ID, so I cannot be 100% sure. But given the parameter that we are giving it, it doesn't seem like it can be very inefficient. Because internal to the representation, I think the Android framework is using an array of references to views to remember all of the subcomponents of your screen. And this is really just doing some simple bound checking, and if the bound checking works out, then it's just going to return whatever reference is at that point. What about the button part? What about the casting part? Are there any questions about the casting part? Because this officially returns something that is a reference to a view, not a button. So in order for this assignment to be happy, the Java compiler needs you to tell it and say that, I know what I'm doing, okay? Even though this is a reference to view, it's okay, okay? It really is a subclass in reality. So go ahead and cast it to a subclass of view, which is button. Now, if you do something like this in C++, you are leaving, C++ is relieving all its responsibility to you, the programmer, to make sure that this makes sense. It doesn't do any type of runtime type checking, okay? C++ is just gonna say, well, if you're convinced that this is a pointer, actually a pointer to a subclass and not just a superclass, go ahead, cast it. From now on, it is now a pointer to a subclass. That's how C++ is gonna say. In Java, it is different. If in reality, this is not actually a reference to a button and you're trying to cast it to a subclass of button, at runtime, the Java engine would actually come back with an exception and say, can't do this. So your program will stop instantly, okay? And if you look through the log of the Android system, it will give you a hint of what goes on, why your program is crashing at this point, and it will probably give you enough information so that you can actually locate this line and say, okay, this is actually not a button, it's the wrong ID, okay? So that's good, because otherwise, if you do something like this in C++, you will just end up with memory corruption because you'll be accessing something as if it is a button, but it's not. And that's not good. Okay. So do we have any questions on line 15? Line 15 is just basically saying, okay, give me the reference to the object that is representing the button that I want to tweak. Is that okay? It's just looking up. Line 16 is the actual tweaking. So let's focus on line 16. Line 16, the first part of line 16 is not mysterious at all. Okay? B is now a reference to a button object. Yep, go ahead.
I thought when you use the word new, that creates the reference.
New is allocation. New is an operator when you use the word new in Java and also in C++ and most other object-oriented programming languages, new means I'm going to allocate from memory and create a new object.
So it just creates the space, it doesn't give the reference to the space.
Say again?
So it just creates space for it, but it doesn't create a reference to that space.
Correct. The new operator itself is really just pulling, like 5 ounces of cookie dough. It's just allocating the resources that you need to make a cookie. But the other part of the new, usually on the same line, is the name of the class that you want to cut a cookie using that. And in open and close paren, sometimes we have parameters inside. That's the actual constructor, and that's the part that shapes the cookie dough to the shape of the template.
So where are you allocating the space here?
It's done by the previous, it's done
Okay,
already
so
by the time we get here.
Between line 14 and 15?
Before line 15 is done, it may be done by super.onCreate, but I'm not 100% sure when it is actually done.
Okay.
But it will be done, it should be done by the time we get to line 15 and 16. Yep.
So it's not like VB where you can set it to pre-fill some parameters when you call new.
When you call new in Java, it typically looks like this. Okay, so you basically say new, and then you name the class. So C is really just representing whatever class you're creating an object out of. And then you can use parentheses and close parentheses. If you just use open and close paren, that's the default constructor. Basically it's just saying, okay, I'm creating an object here, give me all the default values. But for certain classes, you also have specialized constructors. So you can specify parameters inside the parentheses. Then you can specialize and say, create a new object, but I want it to be initialized according to these parameters. So it's actually doing two operations. This is pulling cookie dough from your stockpile. Okay, this is actually shaping the cookie dough to the cookie that you want to create. So this is actually a two-step process. When you see a line like this, okay. And that is usually done in the context of creating objects representing screen elements. It's usually done by the framework itself, and that's why you have the manifest file, the XML, manifest file, and also the layout file. Those files are intended for the framework to read, the Android framework. So the Android framework will read that file inside your APK file, and then what it will do is it will go through that file and say, okay, I need to create a button. This is where the button is supposed to go, and this is the subclass that I need to use to create a button. And that's why it's in a separate file, because the Android framework will read that file and do all the will do all of this kind of behind the scenes. By the time we get to onCreate, I think that should be already created. I'm not 100% sure, but I'm fairly sure. If not, it's handled by the onCreate method of activity. So that would take care of that. But anyway, by the time we get to line 15 and 16, you can count on those objects already created. So getting back to line 16, the first part of line 16 is not mysterious. B is now a reference to a button object, and you're just using a particular method of a button, okay? In other words, you're basically just saying, hey, button B now wants to change its on-click listener to something, okay? Which is exactly what you would expect, right? Okay, we want this button to have a particular callback. What is kind of surprising is the parameter that you're passing to set on-click listener. It's passing this. So what is this?
Current object.
Is the object that is executing this method. Okay, it's the reference to the object that is executing this method. Okay, that's good. But what kind of object is that? No. B is the button. This is a my activity. The object that is performing onCreate, which eventually is this, is a object of my activity. And if you check the type requirement of this, what do you expect? We got a few choices here, okay? In other words, if you look up set on click listener, if you look up that method, what do you think that method is specifying as the required type of this parameter? We got three choices. I'll let you pick one of those three. First choice is my activity. That would certainly pass, and meet the requirements. Second one is activity, which will also work because you can always cast to a superclass. That's okay, no problem. And the third choice is on-click listener, because you can also cast the class of an object to an interface that it implements. So which one out of these three is the answer?
What was the question again?
I need to roll back my screen recording and play that portion again. I really need to have a little quick interface so I can do the TiVo thing in class. Bloop, 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 and then just kind of redo the thing. Okay, the question was, what is the type requirement of this parameter, of the parameter this, of set on click listener? And
This is on-click listener.
It is on click listener. And that's the whole reason we are going through this exercise, to make this class implement on-click listener, specify the on-click method, is so that we can pass the my activity object as a parameter to set on-click listener for the button.
Isn't that pretty much the green? The picture you showed us, isn't that pretty much the green thing, the green box with the two buttons?
Okay, so let's go back to that picture. I kind of understand your question.
Yeah.
Okay, so in this picture, this has nothing to do with instances. Okay, this picture is displaying the classes and the interface. There are no instances involved in this case. Okay. Am I doing okay so far with that concept? Okay. Now we have an object, right? In other words, we have an object that is created using the burgundy triangle. We use it to stand out an object. So what this is saying is, if you have a reference, okay, if you know how to find an object of the purple class, now I can change that reference and say, oh, you know what? It is not a reference to a purple class anymore. I want to change this to become a reference to an object behind a green rectangle. And that's permissible because we know this class, the burgundy class, is implementing everything that the green rectangle is expecting. Am I doing okay so far? No? Yeah. Okay, if we go back to the code, I can actually tell you what that means. Okay. So if we go back to this code here, this itself, okay, if you just refer to this, it is a reference to a class myActivityObject. Is that okay? Is that established? Okay. So as a reference to a myActivity class object, we can cast it on the fly and turn it into a reference to a on-click listener object. Because on-click listener is an interface, and we know that this class myActivity is implementing on-click listener. And that's why we can do that cast automatically. So even though set on-click listener is expecting a reference to a quote-unquote on-click listener object, this can be casted to that interface because it implements that interface. Is that okay?
Yeah.
Okay. So the question now is, well, how do I know that Jack is actually telling me the truth, that he knows what he's doing? Most of the time you don't, but when I'm good at my job, you don't. Okay, on certain days when I'm not so good at doing my job, then you know that I don't know what I'm talking about. Okay, I know it doesn't inspire inspiration. That's not inspired confidence, let's just say. Totally inspired. Well, but that's why I'm going to teach you guys the technique to check what I'm saying, which is more important than what I'm actually saying. Is that making any sense?
Good to know.
I'm doing what politicians do. I'm doing the opposite of what politicians do. Politicians tend to tell you, trust me, I know what I'm doing. And in fact, don't look up anything. Don't check anything. Just listen to me and do what I think is the right way to do things. Vote for me and it's all good, right? I'm telling you the opposite. Don't vote for me. Check me out. See how you cannot actually trust me, and these are the references that will prove why you cannot trust me. Okay, so let's go ahead and do this. Android set on click listener. Search engines are great because now we can just search like this. Go to view Android developers, and what does view have anything to do with this? I thought we were dealing with buttons. So this has to be the wrong page. Let's go back to the previous page. No, hold on a second here. Okay, button is here. Where's button? It's one of the subclasses. It's not a direct subclass, but it is one of the 56 others. Okay, because if they list all the subclasses, it's going to be a long list. But if you click 56 others, it will show you a list here, and sure enough, button is a subclass, not direct but indirect subclass of view. Okay. So now, my next task, once we know this, we're actually on the right page. Now we look up, on set on click listener. Sure enough, the parameter is an interface of the type view.onClickListener. So we have just verified the stuff that I just talked about earlier. Is that making sense so far? Now, why do you think this is important? This whole process of being able to look up the documentation and being able to double check what I just talked about. Why do you think that part is important? Can I possibly, in any reasonably period of time, talk about every single method of every single subclass of every single package in the Android framework? No, absolutely not. And it's not reasonable, because by the time I get to a third of that list, you would have forgotten 50% of what I just talked about. Okay?
You couldn't even do it in an unreasonable amount of time.
Because by the time we're at 25% of that list is revised. The next version of Android is out, and now we have new and better way of doing things. Yep. So that's why it's important to know how to look up online documentation and how to search for the specific things they're looking for. You can see that I use Google to get to the page, and then once I get to the page, what did I do? I search it within the page using F3 in Google Chrome. Yep.
My question is, though, is that don't they keep the API resources all the way back to whatever they support?
They keep track. Most things are backward compatible. This is one thing that I really, really appreciate of any type of programming language and framework, because you cannot find backward compatibility like this in certain environments. PHP is infamous for not being backward compatible. You upgrade to a minor upgrade, so we are talking about versions 5.8.11 versus 5.8.13, and the new one will break existing code. It just doesn't work. Okay, you look at Visual Basic. How many times have Microsoft upgraded Visual Basic to the point where existing programs do not even compile anymore? Often. Yep.
So does it just
Go ahead.
So does it just provide all the older APIs, or do they also modify the current?
As far as I know, the portion that I have read, the Android API levels are usually backward compatible. In other words, if something was implemented in API level 1, it would still be usable in API level, let's say 19, which is the current one. So if you write an application using API 1, it would still be okay. Now, from time to time, they do deprecate certain things. In other words, they would say that, well, this is from API 1, but we prefer not to do things this way anymore, and they will give you a rationale of why they're doing this, why they're deprecating this particular API level 1 feature, and they will give you a substitute and say from here on, we want people to do it this way because da 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 da.
Did it automatically do it for you?
No. The documentation
Right.
is really just saying that this feature is not is deprecated. It's not. You should not use it if you're writing new code. Basically, that's what they're saying. But they typically will tell you what else you need to do the same thing, and they will give you a rationale why that is the case.
Yeah, like you have a one API function from level 1, but down the line they found a security issue with it, so it has to be completely rewritten, but the output is different. Can they reuse the same name later on?
I don't think they reuse the same name for something that does something differently. At least from the effect would be different, so
Yeah.
they would not change the name. It's really just good programming practice to do things this way. Perl is like that. Unlike PHP, Perl. If you upgrade Perl from 5.8 to 5.10, they would have certain features that are deprecated. It's just saying okay, these are the things that we do not encourage people to do anymore. Okay, if you're writing new code, don't do it this way. Do it the other way. But if you have older programs, using the deprecated features, they will still limp along, even though the compiler may give you some warning and say, hey, this is really not a good thing to use anymore. They will still let you do it. So my observation is just that that the Android framework has deprecated features, but they have not taken out anything, or worse, changed the meaning of something. Because changing the meaning of something is really, really bad, because it doesn't break your existing programs, and yet they won't do the same thing anymore. They would be doing something differently.
If they had nearly the same thing but it was slightly different, what would the naming practice be for the newer function?
For the newer function,
Yeah.
the newer function would have no particular standard of relating to the old name. The old name will refer to the new name and say, this old name is now deprecated. Use the new name to do, about the same thing. But as far as I know, they do not change an old name to do something different.
And this is like output could be very minorly different, but the overall function is the same.
Then they would not change the name. If the observable output, both from the GUI side and also from the effect to other object, is identical, then they won't change anything.
Like maybe like the function originally had an output of like an array of 3 items. The newer one had an array of 4 items.
Then the question is, will it break any existing code? If it does not break any existing code, there's no need to rename it. Yep.
On the example that you were just on, on Moodle.
I just put it on the screen again. This one or the one?
Yeah. Set on-click listener is a method of on-click listener.
The method is the method name is set on-click listener
And that's a method
of view. Class view has the method set on-click listener, but because a button is eventually a subclass of a view, that means it also inherits that method from view. In other words, this will work for any view. Any object that has a superclass of view can use this, including view itself. Activity, if I remember correctly, activity itself is a view also.
Why would you have set on-click listener a method of view and not on-click listener the interface? Or in the interface you define it for your own needs.
Okay, this as a reference to an object of my activity is already implementing on click listener, and that's why I can pass this as a argument to the method set on click listener because the types match. Okay, let's kind of go through this. Okay, I'm gonna use a text editor here as my little whiteboard. Okay, so let's go through a few things here. Okay, the few things that we have to remember is my activity extends activity, and that's how we can get to the method on create. Okay, because it's inherited. It also implements on click listener, which is an interface. Okay, is that okay? Okay. Next thing we need to know is on line 16, the word this is a reference to a my activity object. Is that okay? Because it has to be an object of that type invoking this method because this method is specific to a my activity object. Is that okay? All right. Because my activity implements on click listener. Excuse me.
You only get 2.
3.
I'm only taking
Well, it's all recorded. We can count it again. Yes, we can abuse the recording for whatever purpose we want. Okay, because my activity implements on click listener, we can cast this to become an instance of interface on click listener. Is that okay?
That's the part I'm good.
Well, that's the language feature too, because my activity implements on-click listener, right? That's the compiler checks it, it compiles, it's okay. So that means when you look at a reference to a object that is of type my activity, we know that you can cast that reference to become a reference to an interface that is of type my on-click listener. Is that okay?
I don't know, I'm trying to figure it out.
Okay. Because that really is the whole point of having interfaces, is so that we can cast a reference of a particular object that belongs to a certain class to a reference to an instance of the interface. So once you cast it to an instance of an interface, once you cast it to an interface, because there's no such thing as an instance of an interface, but once you cast it to an interface, it would lose everything else that it knows about this particular subclass, my activity, except for one thing. In this case, it has a method called onClick. That's it. And that's all it needs to know.
So when you're casting it to the interface, that's basically like putting the method into the interface.
You are masking the rest of the object and only exposing what the interface is supposed to expose. It's kind of like there's one analogy where you might find it useful or not. Is when we look at objects, for those of us who can see colors, then it really is I'm actually more referring to animals that cannot actually see colors, so that would not be applicable to those animals. Actually, it still applies. It has nothing to do with whether we can see colors or not. Okay, so let's say you're looking at objects and it has all kinds of colors. Okay, so when you look at it as an object of a class, you see all the colors, you see all the features of that particular object. Now you can look at an interface as a lens or a filter, an optical filter of a particular color. So when you look at the object through that filter, then it becomes, oh, okay, I cannot see anything other than the color that is passing through that particular filter. Am I making any sense? So let's say you have, green, red, blue, brown, and all kinds of other objects. Once you use a green filter, then you cannot see the other colors. Only the color or anything that is green will pass through. That's basically the job of an interface, is to say, well, I don't care about anything else, okay? My question is, does it have a yellow circle and an orange circle in the example that we had earlier? If it does, that's all I need to know. But from now on, when I refer to this interface, when I refer to this parameter of this of this method, all that I know, all that I can access would be the yellow circle and the orange circle. I have lost access to everything else that the burgundy, teal, or the blue triangles know.
No, I get that analogy. I've understood that from the beginning. I don't know, something's not clicking though with this. I guess I'll just listen to what you say.
Okay.
See if it clicks.
Okay. All right.
And then see if I understand about the buttons. The somewhere along the line, buttons were created. Button objects were created.
Right.
Right now, we don't know where it is being created.
That is correct.
Okay. In a activity, you can define any number of buttons that you want.
Right. You can drag and drop all the buttons that you want. You can even create new ones on the fly.
Okay.
Yep.
So in that in the tools, when you add buttons in, it's adding code somewhere to create these buttons upon the instantiation of my activity.
That is correct. But that is done outside of your control.
Out of my control.
That is done outside of your control, because what happens is, when your application first starts to execute, when your APK file, after the APK file is installed, it will have all these files that we talked about. They're all going to be expanded into a particular folder. So when you click an icon on the screen to start an application, what the Android system or what the Android framework is going to do is it will go through some of those files, the XML files, to figure out, okay, we are supposed to start this application. How am I going to do it? Okay, so in the in one of the XML files, it will basically say, okay, we have a default screen to create. This is one of the this is an application that has an interface, because we can't have applications that have no interfaces, right? Background processes. So this one does have an interface, and it will name how to find my activity using the full package path, and it will name this class and say the main screen or the initial screen would be representable using an object of my activity. So that's one side of the equation. But on the other side, you have the layout file. Layout main or main layout. Is the one that we saw earlier on Monday. So that layout XML file will further tell the Android framework what do we need to create to put onto the initial screen. Because otherwise it's just one screen with nothing on it, right? So now you can put buttons, text boxes, and whatnot onto the screen. But everything that you see on the screen beneath the behind the scenes is represented by a Java object. So the question is, okay, so what object do we use to represent this text box? What object do we use to represent this button, and so on? So the Java framework will read through that XML file and parse it, and then understand, oh, okay, so this is a button, but it's a special button. I need to use this special class provided by the package in order to create an object to represent that button. Okay, this button here is normal. I'm going to do something differently, and so on. But that's all happening behind the scene before you have control in on create.
So when you create an Android app, it creates an XML file that tells Android that tells Android what objects to create within Android, and then in the My Activity object, you're essentially just saying refer to those.
Already
Okay.
created objects.
Okay.
Yes.
But then how do you know the button name? It's within the name you.
The button name is actually, there are two places where the button names are defined. One is inside the XML. It is utilized inside the XML file, so that you can basically, number or ID, the items.
Okay.
And then you also have a separate file that defines, these things. There's a separate file that has the definition of these things, so that in Java it is accessible. Because otherwise, these things are inaccessible in Java. It's sitting somewhere in an XML file, which has nothing to do with the program that you're running in Java.
Right.
Right.
So through your Eclipse, when you're adding the buttons, you assign a name, so you have to know that name when you want to refer to it here.
That is correct. And that's why sometimes, if you do certain things, Eclipse will give you a little, either error or warning symbol, because before you recompile the entire project, some of the newer definitions are not made known to the editor. So the editor will think, oh, we don't have this method, or we don't have this class, or we don't have this resource ID. But when you compile, it will go through the entire process of refreshing everything. Then it will actually compile and say, okay, it's okay now, because now that I have seen the other files, the updated version, I'm now convinced that everything is fine. Okay. So are there any other questions about these two lines? Those are very good questions, because we are now questioning and understanding what is happening behind the scenes before we have control, at these two lines. Yep.
Does it have to be a button? Can it be anything else?
What does what have to be a button?
I mean, like when you click on the button, it's basically a callback.
Right.
Do you have to click on? I mean, does it have? Is it specific to a button? Can it be a checkbox? Can it be an empty?
That's a very good question. Okay, so let's see whether we can use our knowledge of object-oriented programming to answer that question. Okay, so the question is, if I understand correctly, is can we use this mechanism to specify an action that we want to perform, but not only with buttons, but with other things? Is that your question? Okay, the answer can be found here, because when you look at, ultimately who, okay, long click. Okay, ultimately, whose method is this? It's views, right? Okay, view as a class. And also, ultimately, who defines or who includes the definition of this interface? It's also view, right? Okay, so when we look at the view documentation, sure enough, we're going to find the interface definition of on-click listener. And there are many of these. Oops, I just missed the one that I really want. I think it was the first one. There we go. Summary: nested classes, including interfaces. On-click listener is a part of the view class definition. Okay. And then the other thing we want to see, it would be the inheritance hierarchy. In other words, we want to look at these 56 eventually subclasses of view. Every single one of these can respond to on-click. So we are talking about not just buttons, but checkboxes, calendar view, compound button, date picker. You just, if you go through this list, they are all capable of responding to on-click event using exactly the same mechanism. Yep. So this is that's a very good question, because that question really helps you understand the power of object-oriented programming. Because by putting this on-click ability mechanism all the way up to that superclass view, now we have just we have just provided that same capability to all of its subclasses. It doesn't matter which subclass, each and every single subclass has the ability to respond to clicking. So are there any questions about that part of the discussion? No questions about that? Okay. We're running a little bit over time, but I think, well, that's a good hint that I need to take roll. See, I keep forgetting about this sort of thing. Bob Irvine will never forget to take roll. He's just a lot more disciplined than I am. In more ways than one. And that's recording. That's being recorded too. It's okay. It's a true statement.
Are you massaging someone to go? So are you massaging someone to go?
Say again?
Are you massaging someone to go?
No, I'm just stating the truth. All right, so this is the roll sheet of today. Just go ahead and pass it around. It doesn't take long because it's a fairly short list now.
No class Monday?
No class next Monday. Yes, we have President's Day, so don't come here because I won't be here.
No class Friday either.
No class Friday or Saturday. Some people teach Saturday classes. I don't see any benefits at all except for Monday, but that's because I don't teach on Friday nor Saturday. Some people teach on Friday, Saturday, and also Monday, so those people would see like a pretty long break. I personally, when I'm teaching in the semester, I don't like breaks because it just really kind of break the train, of material.
Spring semester is the worst because you have spring break right in the middle.
Yeah, exactly. Some people like spring break. I would much rather move that into the summer vacation and just make the summer a little bit longer by a week. Anonymous classes. Okay, this is what you need for the homework assignment. So that's why we gotta get to this part here. Okay, the previous approach has one problem, and it's a serious one. With this approach, what if you have two buttons, and you want to customize what happens when these two buttons, when one of these two buttons are clicked? Well, this method doesn't work anymore because the class myActivity can only implement onClick listener once. So you can only specify one onClick method, and with one onClick method and two buttons that you want to customize, this approach just doesn't work. It runs out of gas right away. Okay, so that's why this second method here is really my least favorite method because it only works for one button, and it's not even that convenient to use. So I would use the second or the last method here. So if I were to pick, how to deal with customizing the behavior of a button, I would either pick the first one, which is the full, pure, object-oriented way of doing things, but it's kind of tedious and cumbersome, or I would pick this way here, which is kind of ad hoc, but it's also general because you can deal with multiple buttons in this case. So let's take a look at this stuff here, at this one here, and see what is going on. It has a lot of the same stuff that we had before. It's just that it looks at things a little bit differently. Okay, so once again we have myActivity extending activity just like last time, but there's one difference now. It does not implement onClick listener. Okay. Now, if it doesn't implement onClick listener, how are we going to deal with onClick listener? Well, let's take a look at onCreate. Now, just like with the previous one, we are overriding onCreate to attach some additional code for initialization. So we'll take a look at, and by the way, this is one single statement. So we'll have to break it up a little bit. So let's start with this portion here. We have seen this portion before. What is it doing? What is r.id.button1? It's returning an integer that uniquely identifies a particular button in this case. Okay, well that's something that we did before, no big deal. We use findViewById, which is a method provided by the view class in order to return a reference to a view based on the ID that I pass as a parameter, just like before. Yep.
So that's giving you coordinates on the screen? Or
the button itself would have those information. In other words, there are methods in a view class object that you can invoke that will return the coordinates and stuff like that. You can actually change it on the fly as well if you don't.
So that's what this is doing, or no?
No, that's not what it's doing. It's just returning an object.
Okay.
It's returning a reference to the object. Yep.
Is there a general limit of how many objects you can have on the screen at any given time?
I don't think it is a limitation that most people have to worry about. I think it has more to do with how much memory you have on the device, more so than the API limitation. Okay, so since it's returning a view, a reference to a view, and I want to use a button, so I'm going to cast it to a button. Now that part is not necessary because a view automatically has a set on-click listener already, so it's not entirely necessary to downcast it to a button, to cast it to a subclass. But it's really just additional checking at runtime, so it doesn't hurt anything except it takes up a little bit more time. But it really is not necessary because a view automatically can use the set on-click listener already. Yep.
It makes it easier to read as well.
Right, so that you can see that, oh, I'm dealing with a button here. Right. And also, if you want to, no, it doesn't matter. You know, it really is not necessary in this case. Okay, so now when you look at this whole thing here, it becomes a reference to a button, okay? Because we downcast it to a button already. And a button, being a subclass of a view, has a method called set on-click listener, just like the last time. Oops, I just clicked something. There we go. Okay. So this entire thing, this part here, is something that we have seen already. It's just that I did not go through the intermediate variable b at all. I'm just combining the two lines into one. Are we still doing okay so far? So up to this point on this line, there should be no big surprises. Okay, we're just combining two lines into one, in a way making the program a little bit more difficult to understand. But at the same time, it's nice because when you have multiple buttons, you don't really need to create additional variables, as intermediate variables that are really not necessary to begin with. What we don't really truly understand is what happens next. Okay, this stuff here, and I'm going to refer to the line numbers. So from line 5 all the way up to line 9, we're doing something that we have never done before. We are creating, or we are defining an anonymous class. We make that anonymous class implement a on-click listener interface. We allocate storage for this new class that is anonymous, has no name. We initialize it, and we even define that it has an on-click method. All wrote into these 1, 2, 3, 4, 5 lines. So let's go ahead and take a look at the details here. When you look at this open curly brace all the way up to this closed curly brace, that really is a class definition, but it's an anonymous one. Which means this class has no name. You cannot say, oh, I want 20 more, I want to create 20 more objects out of this class. Nope, cannot. Now because the class itself is anonymous, it also means that it is a one-off kind of thing. You can only create one object out of this whole thing, because it's an anonymous class. Now whether you can combine this with array operators and create multiple of the same thing, that I do not know. Okay, I don't know Java well enough to answer that question. But we can certainly create a one-off object out of an anonymous class because that's all we need. The anonymous class has a method called onClick. So as any class that has an onClick method using this particular signature, this anonymous class can implement the onClick listener interface. Is that making any sense? Because remember, an interface is really just placing a restriction on a class and say, can you do this and can you do that? Well, this anonymous class can deal with onClick, so it can implement a on-click listener interface.
So can you have an anonymous class that doesn't implement anything?
Yeah, you can.
So how would you write that?
You just have nothing in between the
just
outer curly brace and
Just
close
write
curly
new
braces.
brackets?
Right. But that would not be a very useful anonymous class. But yes, you can. Okay, so this is the class. I keep clicking the link here. I have no idea why they turn these into links either. Okay, there we go. So this is the class definition. It is anonymous. We are associating that with the on-click interface. And this new applies to the anonymous class. What do you do when you say new on an anonymous, any class?
Allocate space for
It allocates space for an object of that class, right?
Okay.
And then this parenthesis and close parenthesis means that we also want to initialize it, okay, using the default, quote-unquote, default constructor to initialize the object. Now, if you don't say anything, the default constructor is just saying, nope, I'm not going to do anything. There's nothing to do when it's constructed, which is fine. Okay, so for the most part, this is just syntactical. Okay, the open and close parentheses here are just syntactical. What is kind of important is on 2 lines, okay, because these two chunks of code are actually identical in many ways, except for button 1 versus button 2. But what really is important is on line 7. Okay, line 7 is special, which is this portion here, because this part is nested within my activity. This portion of your program has access to everything that my activity knows. In other words, if you have additional methods, if you have additional fields that you have defined with my activity, which is fairly typical because people like to put in additional stuff with any type of activity. This on-click method has full access to everything inside the my activity subclass. Now that makes it very handy because that means the button being clicked can now directly trigger actions that are specific to my activity without you having to set up all kinds of references ahead of time. And yet, this is not a one-off thing. We can do basically the same thing again, but this time we apply that to the other button. So when you look at this portion of the program, it is dealing with the other button, button 2, because we have button 1 as one, and then we have button 2 as the other one. This one deals with button 2. So the code on line 14 is completely independent to the code on line 7. Button 1 can do blah 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 blah. Button 2 can do yada yada yada, and those two things are completely independent.
Yeah. In Oracle's Java tutorial, they talk about what's called Lambda. Is that the same thing as this anonymous class, or
I think Lambda refers to Lambda calculus, and those are very specific programming language theory type of thing.
They have a terminology called Lambda in Java. I'm not sure if it's Java 8 or what it is.
Let's take a look.
Yeah, Lambda expressions.
Yeah, Lambda expression is a very theoretical kind of thing. Suppose members of this social networking applications
It
represent.
said something at the top about anonymous classes. First paragraph.
It's a beta.
First
Shows you
paragraph.
how to implement a base class without giving a name, although this is often more concise than a name class for classes with only one method. Even an anonymous class seems a bit excessive and cumbersome. Lambda expression allows you to express instances of single method classes more compactly. So it is probably something that can replace anonymous classes eventually, but Java 8 is not released yet.
Yeah.
So that's a good find. I'm definitely interested in this feature, but it looks to me that it is a syntactic change that makes certain things more convenient, but not necessarily making certain things possible, whereas it was not possible before this feature. So that's interesting. In certain programming languages, you can actually pass anonymous functions, subroutines, as a parameter. Java cannot do that for one reason. It's fully object-oriented, so whatever you pass, whatever you assign, they all have to deal with objects or interfaces. So I think the lambda expressions is one way to kind of get around that problem, to try to make things more concise. All right. So, yep, go ahead.
Back to the code and where do you implement the interface?
You mean here?
Yeah.
The fact that we are using this word, which is the name of the interface, ahead of the anonymous class definition, is the syntax in Java to basically say this anonymous class is implementing this interface. And the open and close paren is really the constructor syntax. So we are creating this class, we're defining the class on the fly, but we still need to fulfill the syntactical requirement of invoking the constructor. So the open and close paren before the curly brace highlighted is really just there to say that yep we remember to call the constructor. The other thing about the open and close paren also has to do with the anonymous class that you're creating can have specialized constructors. That would be kind of weird because how would you name the constructor when the class itself has no name? I'm curious now, so I need to find out. Okay.
Wait, can you repeat your question?
That's the question. Okay, the default constructor I can kind of understand because it doesn't do anything. But what if you want to have a specialized constructor of your anonymous class?
Give the reference.
But how do you name the constructor? Because the name of a constructor is the name of the class itself. So if your class itself is anonymous, it has no name, then the constructor has no name either. So that's why I'm just kind of curious, how can that even be done? Stack Overflow, anonymous class, and then let's look for constructor. Okay, the syntax of an anonymous class. As mentioned previously, an anonymous class is an expression. The syntax of an anonymous class expression is that of invoking the invocation of a constructor, except that there's a class definition contained in a block of code. So this is our anonymous class definition, all the way from here down to here. The new applies to the class we are creating that the open and close parentheses deal with the constructor syntax. And it always has to be associated with an interface. So this part is kind of quote-unquote hard-coded. There's no variation to this. So it has to be new, name of interface, open, close paren, and then you have the anonymous class definition in curly braces. That basically is just a set syntax in Java to deal with this. Note when you implement an interface, there is no constructor, so you use an open empty pair of parentheses. Parentheses that contain the arguments to a constructor, like a normal class instance creation expression. Okay. You cannot declare constructors in an anonymous class. Okay, I'm satisfied.
Okay.
Because there's no way to specify a constructor when the class itself has no name. Because the way we name constructors is the name of the class itself.
Mm-hmm.
So if the class has no name, how do you specify the constructor? So there you go. You cannot specify, you cannot declare the constructors in anonymous classes, period. So the open and closed parentheses are really just there because it is quote unquote required, but you cannot really put anything in between because it has no ability to have constructors defined in an anonymous class. So yeah. So it just syntactically has to be there.
But it just uses a default constructor.
Well, but in this case, the default constructor doesn't do a single thing. So
Right.
even if you have member instance variables, you cannot have anything to trigger the initialization of those variables.
Yeah.
Yep.
Well, go back to your example.
Mm-hmm.
So there's no way of initializing things, you're saying?
The only way you can initialize is to say, int x equals 10. I think that still works.
Mm-hmm.
Okay, because the initialization is associated with the variable itself,
Yeah.
and not an additional piece of code attached to it.
So in this piece of code, you're creating a new method.
I am defining a class with a method onClick, and that make it implement the onClick listener interface. And so that's the definition of the anonymous class. But I'm also doing the new operator, and then the open and close parentheses are really only there syntactically to say that yes, we quote unquote do the constructor thing, but there's really nothing to do.
Right. Can you define redefine the method onCreate?
OnCreate?
Wait, it's like, so here you have a onClick method.
Yeah.
Right.
Uh-huh.
That you're implementing.
Yeah.
You within here implement other methods.
Yes,
more than one
you can
method,
specify
right?
other methods, but they will be useless
Because they won't be invoked.
because they cannot get through the onClick listener interface.
Yeah.
Okay, the object that is created here is not accessed as an object of a class blah 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 because the class itself has no name. Other people can only know of this object that we have created as an interface or an object that is behind the onClick listener interface. So you can define 20 gazillion methods here. Syntactically, it is okay. But in terms of runtime behavior, the caller doesn't know a single thing about anything beyond onClick. So all the other methods that you define here are completely inaccessible. The only reason why you might have additional methods defined is what you want to do in onClick is so complicated that you want to use subroutines or other methods to help you break down the process. So that's more for your purpose of breaking down a complicated algorithm into smaller chunks than anything else, because none of that can be exposed behind the interface. In other words, if you want to define additional methods here, you might as well make them all private. Because if you make them public, there's no one who can refer to the class to begin with, right? You can make it protected, but nobody can inherit from this class either. So they're all going to be private anyway, because there's no other way to access the other methods inside this class definition. So they're all private. They're only for breaking down the task that you want to perform in onClick just for better organization of your code. Right. Any other questions? So I'm hoping none of you is going to make the onClick method of this homework assignment so complicated that you need additional subroutines to do it. The homework assignment is fairly easy. Yep.
Can I take it back?
Say again?
Can I take it back?
Can you take what back?
Yeah, the homework.
Yeah, you can just erase it and then turn it in again.
Oh, okay.
Yeah. Unless you have submitted the entire exam already. You did?
just want to review the code if there's a.
Oh, okay. You might be able to review it if you go back to the exam. Oh, I don't know about that.
I mean, I had some modifications.
Oh, okay.
I mean, it worked, but that way.
Okay. All right.
So, in this example, on-click listener is interface.
Right. This is the name of the interface that the anonymous class is implementing.
That the anonymous class is implementing. Okay.
Right.
And then, and within this interface, there is a method called onClick.
Right.
That it is being implemented here.
Right.
And then, so you said the new creates an anomalous object.
It creates an object of the anonymous class.
Okay.
Right.
And and this anomalous class is not a subclass of any class at all.
This syntax does not seem to allow me to specify it is inheriting from anything else.
Yeah, so in this anomalous class, you only could within this anomalous class that you create, class object that you created, you could only implement.
The outside world will only know about the onClick method of this class
It can only implement
through the
yeah,
interface.
okay.
Through the interface.
Okay.
Okay, so here's the question. I know I'm running way over time here. Here's the question. What if I want this anonymous class to inherit from something and it's just not doable here? Well, don't make it an anonymous class. That's all you have to do, because it can still have class definitions inside my activity to implement onClick listener. And as any subclass, okay, embedded class definition, they still have full visibility of everything else in my activity. So don't make it anonymous, just make it a normal named class within the definition of my activity. And when you are ready to create an object out of it, just say new and then name that class that is internal to the my activity definition, and you're all set. This is really just a handy way of doing things so that you don't have to say, oh, button one class, da 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 da, or class button one inside my activity and go through the full syntax of defining a class. It allows you to specify something, just a one-off thing. Okay, do this. Okay, that's it. So if you want anything that is complicated with inheritance and all the other stuff, make it a normal class definition, and everything is good again.
So
Yep.
if this onClick listener had two methods,
Then you would need both. Yep.
Okay,
Because otherwise the compiler would complain and say, okay, you cannot implement that interface because you're only providing one and the requirement is both.
Okay.
Right. All right. So are there any other questions related to this homework assignment? Right. So I think we are ready to do this homework assignment. So I'm going to assign a due date, which is going to be next Wednesday. So you have 1 week from today to do it. And because we have a long break, so that typically means people won't get started until next Tuesday.
Correct. As long as you realize that.
Yep.
This is it. This is the interface.
So I'm going to stop the recorder now and